Hi, I welcome you all in today's exercise of building dashboards onto Cloud Pak for data using R as a programming language and Red Hat OpenShift infrastructure. I will demonstrate building data dashboards generally built out by a programmer or a data scientist for number of line of business users or just for specific departments or processes. Generally, dashboards are an information management tool that visually tracks, analyzes, and displays metrics and key data points or key performance indicators to monitor the health of a business. Over here, you see our different examples of these dashboards. This one is a Genome Browser. This visualization is based on circos. It's a way of visualizing whole genomes in the circus style. The plot shows a number of layers starting from the outer layer, representing different colors, sizes, and these distinguished chromosomes moving from 1 to 22, and then X and Y. Inside the chromosome ring, you can see a line representation of copy number mutations. And when we expand this, more details on the precise copy number and the specific location is revealed. We can visualize these different stats for different donor IDs, resize the factor. Pretty informational. Now, moving on to another example of a dashboard. This is the one. This is a dashboard for tracking tweets around conferences and events. Describes how many tweets are done, what are the most liked tweets in the last 12 hours. Over here we are searching for RStudio Conf, since this is a general example for a dashboard. We can definitely customize it for, let's say, clients like Disney, Marvel, or any other tweet with a hashtag. And then over here you can see top Twitters, top hashtags, top words, and then top emojis. Very beneficial to find out the sentiment for, let's say, a movie. Then tweet wall gives you the different tweets coming from different people at the same time and put them onto one particular dashboard that's most relevant to your particular business and are the topmost. Then gives you the tweets from media all in one page. You can explore more. You can schedule session day, start, end date. It's amazing to see how the scattered information on web can be totally refined and presented on a single screen. That helps to improve your work, business. Now this another one is an informational dashboard. Shows the birth location of all the players who participated in 2018 FIFA World Cup. Gives you all the groups. Let's say for this one, Robert Firmino, Liverpool club, place of birth Brazil. And over here is Pepe, date of birth, place of birth, playing position. Very informational and visually very useful. Dashboards are customizable. We can customize them in the most efficient way to track multiple data sources because they provide a central location for business to monitor and analyze performance. Real-time monitoring reduces the hours of analyzing and long lines of communication that previously challenged business. And you can customize them For a department or company behind the scenes, a dashboard connects to your files, attachment, services, and APIs. But on the surface, displays all the data in form of tables, line charts, areas, stacked area, code diagram, network, arc diagram, edge bundling, most commonly used ggplot. For this exercise, the instance of Cloud Pak for data is implemented on Power Systems, leveraging Kubernetes infrastructure of Red Hat OpenShift cluster. This OpenShift cluster is built on Red Hat OpenShift container platform that provides a secure and scalable multi-tenant operating system for enterprise class applications. It also provides integrated application runtimes and libraries. All in all, gives you a protected environment for running your R programming language and importing your data. Today's exercise is co-hosted by Brian Kelly, who will take us on a deep dive of OpenShift Container Platform. Here you go, Brian.
Okay, that sounds good. So, all right, so this is Brian Kelly, and I work for IBM as a client technical architect. For about the last year, I have been specializing in the implementation of OpenShift Container Platform and Cloud Pak for data on the various platforms that are supported, x86, Power, and Z-Linux. Here you a little overview of how to get started. You will need to obtain all of the software pieces from Red Hat, unless you're going to use a cloud provider. So what you're looking at here, everybody, is a OpenShift cloud or OpenShift container platform that is running on IBM Power servers inside the IBM Garage. I'm going to show a little bit about how you go about setting up the systems and what you're going to need to have done prior to building or adding in the Cloud Pak for data, which Gautam is going to show you in a little bit. So the first thing that you need to make sure is that you have all of your Red Hat software either downloaded and available to install it. If you're using a cloud provider, most of the time the cloud providers will give you access to their versions or sanitized versions of the operating system and OCP that you'll need. You will need to have your own license capability, so a user ID that is part of the Red Hat world that you can register software in. You will need that. You may also need a pull secret from Red Hat, which if you've done Red Hat software downloads, you'll know that those pull secrets are required to do most of it anyways. So what you're looking at here is the first screen as you log into OpenShift Container Platform. I'm signed on currently as a normal user. This is the default administrator screen piece that this gives you the access to add projects. As you can see, we have a list of projects here. Here's Team 1 through Team 6. This was for our hackathon that we did internally with IBM. Each one of these projects are separate namespaces inside of OCP. And if you run any OpenShift containers in that project, they would be running here. The projects are segregated. They do not share product between each project. They do not share data unless the clients wish it to. This shows that if you have multiple developing teams and you wanted to keep them all separate, for HR or IT or anything like that, you can do that very easily here. We also have a list of installed operators. These operators, depending on what you have, and as you see, there's nothing listed here. Depending on which version of OpenShift you have, these operators can be a full list of all the add-on pieces that Red Hat and other vendors are supplying. There are certified ones and there are community versions of them. Just like anything else, as you probably all know, OpenShift or OCP has a completely open version that's called OKD, and that is basically the same version of Red Hat OpenShift, but it is in a open source client or community edition. So you have full access, do anything you want. It'll also run on OKD, is supported on some other operating systems besides Red Hat. It's Fedora CoreOS, currently on CentOS. CentOS 8 sounds like might be after the announcement this week. Sounds like CentOS 8 may be the last supported CentOS true full Linux world that they're going to continue in that life cycle. There we go. So here's the operator hub fully populated. This is on an x86 piece, and the one that I had originally showed you didn't have anything because I was signed in as myself, and I was an administrator a cluster administrator. All right, so as you see here, these are the ones that are offered. These are operators that are offered by vendors and Red Hat that you can add to an OpenShift cluster. Here's one from AKA. You have the official supported version, and here's a community version. So there are a lot of the vendors will supply both a community version, which is wide open, and you may have to do some a lot of configuration to make it work, or the cluster here, like the ones that are fully supported, have been set up, ready to add in without too many steps or too much trouble. Here's the Anaconda Team Edition. If you are an Anaconda user and you want to use and have team licenses, you can install a Anaconda team here, and they'll actually sets up links and things like that so that you have a route. You can click on it and it'll actually go out to the Team Edition website, and you can add in resources or download resources into the cluster. It's Apache Spark, and there's a bunch of them. Over here on the left-hand side, you can see that there are Red Hats. There's certified ones, and then community ones. Depending on the system platform, you may even see in the version of OCP, you may see IBM listed there too. Otherwise, we are in there with, let's see if I can find one real quick. Storage. I know there's some in storage. All right, so this is just all the different storage CSI drivers and capabilities that you might want to use in OpenShift. As you can see, here's the IBM Spectrum Scale, and then there's the community version of Spectrum Scale. Portworx is here, but again, Portworx is only supported on an x86 system. Here's the block driver for CSI. Here's the OpenShift container storage that Red Hat has been adding and making the default for most systems, especially for an x86 cluster. Okay, from there, over here on the left side is your design world. If you are a administrator of cluster, when you first come in, the first dashboard you'll see, this gives you an overview of the cluster and what you've got running, how many nodes are in the cluster, how many pods are running, the storage classes, the number of persistent volume claims that you've got defined. And this shows that I have one pod here that's in an unstable state. We show that we have a total cores. Now these are cores. These are not full CPUs. This is the shared core pieces. We have 448 in this cluster, and currently we're using 15.67, so about 16 virtual CPUs. How much memory is in it? There's 1.86 terabytes in this entire thing, with 213 gigs being in use, and the file system is set at like 4.5 terabytes, and we're using 1.5 of it. Over on the other side here, we have the activity stuff. You can look at all the events are going on. Here's that one that was talking about, that's a readiness probe. And so the DB2 warehouse console has got a problem. It couldn't connect to something on a ready the clusters, the container is probably not running correctly. All right, so let me get over here to see what you guys really want to see. I'm sure is the things like pods. All right, so as you guys know, containers are all pods. You can see here that because I've chosen this is currently the default project, nobody's got anything running in it. We can change this to say all of them, or you can change it to be just your own projects. Let's go down here. So like this namespace and project is called Zen. This is where CP4D lives. I'll give you a little insight here. Currently in this system, as you see, there's 245 current pods running. None of them are in a pending state. None of them terminated. None of them are in crash loop. 33 of them have completed. Completed pods are probably okay. Most of the time, let me go over some real quick over here. We'll take a look at some of these. We'll turn off. And depending on your release, you may have a different little screen here where you get to set the filters. These are filters. This is currently a 4.3 OCP with Cloud Pak for Data 3.01 installed. So here's an open scale, a DB2 warehouse, Spark, another Sparks, and as you see, there's just lots and lots and lots of containers that are running here that have completed. Those are okay because they're probably pending a trigger from another pod to say, oh, I need you to come up and do something, or it runs one time and then shuts down. These ones over here are all running. We'll go back to the running ones. As you see here, in here you have a pod name, right? The namespace that it's running in, who is the actual owner. So this stateful or deployment or stateful set, a replica set, either one of those guys all can own a pod, and they can, and that's who owns this one. It's running currently on this worker node, right? And it is running and ready. And then you also have our 3 over here. And this here's where you can edit a label, edit an annotation, edit the pod if you wish, or actually delete it. All right. Next piece we have are like deployments. Lots of deployments inside of Cloud Pak for Data. As you can see as we go down in here, there's an index one and an analytics. Some consoles, okay, and then deployment configs. As you see here, I don't have any deployment configs because everything I've ordered or installed here is a product from an outside world or from IBM or Red Hat, so I didn't have to build a deployment config. Stateful sets, all the stateful sets here will tell you this is what the labels you're going to set them all, what namespace, the status, how many pods do you want it to be set at, how many pods are running currently, and then you can do this collector set. The secrets are basically all of the secrets from every package that you have to put in. There will be an admin portion of that package, be it an add-on or any of the Cloud Pak for Data things, and so they'll have a secret that are built as it goes in. Config maps. Almost every one of the systems has steps for the config maps, and they normally run them in steps of like 10, 15, 20, 20. These are all just little different steps that have been done. As you see this here, the WKC Lite is the base Cloud Pak for Data world. I know that by just the system and doing it. And here's one for the AI OpenScale. And some streams. If you have streams that are supported, current, and let's see, then we'll go on from there. So then there's cron jobs that run in each one of them. These packages have cleanup jobs, they have deployment jobs, they have all sorts of different jobs. So you can see here, there's a list of those cron jobs, and then these are actual jobs that can be run. The secret generation job, right? So that's for the base. And those may run at any given time by a call from a pod or a deployment or whatever happens to be going on at that time. Some daemon sets, we don't have any. The replica sets, everything here, okay, we want to make sure that I have 1 of 1 pod, 3 of 3 pods, whatever we're doing there. This is basically just an overview, so I'm not going to get too deep in here. But as you see, if you go into it, it wants to know what namespaces, the labels, the pod that was doing it, if there's any tolerations, how many annotations have happened, and then who owns it. This is actually the deployment or the stateful set that will owns it. All right, replication controllers, I don't have any done. And horizontal pod scalars, there is one set up, and that one's from a project, and that allows it to go up and down. I can add and subtract the product, the application, add on whatever you want. It has the ability to scale horizontally pods. So then we got the network side. So we go into the network world. As you guys all might know, the everything inside of OCP and Kubernetes is a service. These are all the services that are currently running, where they're running, the pod, any labels and the namespaces that they have. And I'll show you, I'm not going to go too deep here. And the main reason is that every one of these products has a service, and some of them have routes connected to these services if you want, or some of them may do it automatically. So that's how they would get access from the outside. And we're going to routes next. So we go to routes. So in the Zen project, as you see here, we have the Anaconda team route. And then this is the Cloud Pak for Data console that Gautam is going to show you later. And as you see, these are right here are the URLs that you'll need to attach to those. Let me go back up here and I will say all projects. So then you'll see some more. Alert Manager, I'm currently running this to an outside logging capability and the management, so it has its own HTTP connection. This is the console that we're logged in right now. Download some workload managers. If you're using Grafana for your performance and monitoring, it'll have one that takes you to the Grafana website or console, excuse me. Image registry, this is the registry where everything gets stored in and out of like a Docker registry. We currently are running Podman and Cryo and everything. And I don't believe that you will see like a Docker registry anymore. It'll all be Cryo and that. Prometheus, again, takes all of the monitoring data that's inside the cluster, sends it to Grafana. The router default, Thanos, if you want to go do Thanos setup, you can. Again, there's the route for the team edition, and then Zen. So if I click on this here, it'll open up a new window, and that's the cloud sign-in for Cloud Pak for Data. I'm not going to go there. I'm going to let Gautam do all of that. If you create any ingresses, some applications require ingress from outside the cluster into the cluster. You'll have to set that up here. If you click on this and create, you'll see that it puts you into a YAML type setup, and you'll need to add all these pieces in. Most applications will give you an idea of what you need to do for an ingress if you're going to do it. I know that a lot of the IBM products will help you step through that, or they'll actually give you that pre-configured. No network policies are configured out of the factory. I just didn't do anything there. Okay, we're going to go into storage next. So in the storage, so we have storage classes. Storage classes are the different types of persistent storage that is available to the cluster. And because this is over in IBM Cloud, you'll see that this has got a lot of them. Let me jump back over here and let me show you the storage classes in the one over here that I just jumped into the OpenShift console that's running on our Power Hackathon cluster. So as you see here, it's only got one storage class, and that's an managed NFS storage. And that is currently all that is supported in OCP on Power. They just announced, let's see, what is it, the 10th, that they will now be able to support in the next release the Spectrum Scale CSI driver so that you could have container native storage from a IBM Spectrum Scale cluster. All right, so based upon that, this means that every persistent volume creation that is asked for is going to get created in this storage class. Notice that it doesn't show over here the persistent volume, only the claims. And I'll show you back on the other screen, I'll show you the actual volumes. Again, it's because I logged in here as myself. So here's the claims. And I will say these are all the teams that I have access to. As you see here, and go down through here. And none of these teams have anything that they have requested as far as a claim. So I'm going to jump back over to this one. This one. All right. So now I'm back over on the other cluster. So here's the persistent volumes. These are all the volumes that the different products have requested. As you see here, WKC, Watson Knowledge Catalog, it has a 60 gigabytes capability. Here's one for the WP CouchDB. He's got 30 gig. And you go down through, here's a bigger one here. The Exametadata data is 100. The Anaconda Team Edition database that it requires, it's got 100 gigs and that. So then you go over to, we'll take this, and here is the volume claim. So if you understand, remember OpenShift and containers, this is the PVC, this is the persistent volume. This is an actual software-defined storage piece, and here is the claim that is saying I'm going to write to it. So if I click on it, it takes me over to the claim, and it tells you that it's bound. If it's not bound or lost, if it's lost or pending, you can't write to it. It has to be in this bound state to be written to. Gives you the capacity. What is it? Read, write once, read, write only. The storage class, as you remember in our Power one, we only had one storage class. So this one would say managed NFS. And then it also tells you which persistent volume was there. All right. So next over here on the left side, we got builds. If you have any build configs that you're going to build product by, any builds that are around, any image streams that you're going to build. So these are all the image streams that came when we installed streams in the product from Cloud Pak for Data. Again, I know that because Zen is the namespace and project that all of Cloud Pak for Data was installed in. All right, real quick, getting there. So next is going to the monitoring. So here's all the alerts that are happening inside your cluster. You can tick on one of them and it'll tell you, so this one's throttling CPU and goes up here, and it just shows you that it has an alert. Doesn't mean it did anything, but it's just an alert. And this is the CPU capability throughout the times. And you can see which, and that one happens to be the RabbitMQ container is using that much. And that's why it was alerted. You can set metrics. I don't have anything set. Here's the dashboards. We're going to go over to, this is a call from outside of OCP into the Grafana world. We'll log in with this. And of course, it's going to be slow. But basically it goes out to the Grafana, and then we can say the dashboards that we want to look at. And so there's the cluster, the entire compute resources for the cluster in the last hour. You can see here we can go to custom time frame if you want to zoom in. We can say for the last 30 minutes. As you see, it gets a little closer. Last 5 minutes, it just gives you a little chat. You have the CPU utilization, the requests, the limits if you hit any, memory utilization, memory commitments. And you can go down here and, oops, sorry, too fast on the scroll. Over here, you can say the quotas. If there are big quotas set, sometimes you can set quotas for namespaces. If you get somebody that has a tendency to overuse their privileges, you could limit them by setting limits in there, but that's kind of an advanced topic. So memory utilization, the receive, and this is now we're down in our network usage, right? See, receive bandwidth, oops, excuse me. So transmit, receives, the container name, container bandwidth. Normally the container communication between the masters and the worker nodes are on a separate network, unless you've configured them totally different, but that's why they give you the container bandwidth there, so you're separated. All right, so that's enough of that one. So then you're down here in the compute piece over here on the left side. You've got how many nodes, what nodes are in my cluster, right? I can drill down to the node, I can click on that, and it goes down and shows the individual node, the CPU utilizations, memory usage, networks in and out, file system usage. Here's all the different labels that have been added to it from the product lines, or products that are installed and running on there. Usually when a pod gets added to a worker node, it'll actually adds a label to it so that it knows what's going on. Notice excuse me, that's not tainted. There's a couple of annotations that have been added to it. It was created on the dates. It's available in different pieces that you can see the node conditions. And then here are actually the pod images that are running on there. This node's got a couple of Spark ones running on it, the data virtualization engine, streams, AI OpenScale. Here's a governance fund for WKC or Watson Knowledge Catalog, model viewer, streams again, washing machine language, operating system runtime. So then next thing you go into is you can go into user management, and here you can set up users, you can change passwords, you can do whatever is allowed to you to do there. Okay, any groups that you have defined, service accounts, the service accounts I talked about, these are all the accounts that the products that have been installed required. So every one of them has one. So you notice data visualization, the deployer default, DB2U, even Cloud Pak for data install has its own, viewer and editor, database, the composer, Anaconda Team Edition, again, Watson Knowledge Studio. So and that's that. Then roles, if you want roles, these are all the roles that can be assigned to a user. If you have administration capabilities, again, it limits or enhances the what you can do or say inside of OpenShift. The bindings here, these are ones that have already been deployed. So the admins to me, as you can see here on this particular one. All right. And then under administration, cluster settings. So it tells you that the last completed version, right? No updates have been there. The ID, the desired releases if you want. I can create an autoscaler if I wish to. We can see we started out here at 435. We went to 438. And then our 4335, 4338, and then we just did an upgrade to 4340. All the namespaces that are in the entire cluster, you can also add, delete, and whatever you want from this one here. Or if you do it from the command line, there's also command line capabilities with no problem. Resource quotas, if you create a quota for a team or anything you want there, you can. Limit ranges, same thing. I can limit the amounts of CPU, data, memory, anything I want to give a container. And then any customized resource things, as you see, there are some that have happened here from installing applications or as defaults supplied by OpenShift. All right. Got them? Anything else you want to talk about on this?
I think thank you so much for giving an overview of OpenShift Container Platform, and now I'll take you from here to sort of open the Zen platform in order to access the Cloud Pak for data. Thank you so much.
Thank you all.
Thank you, Brian. Coming back to our Cloud Pak for data instance. So as you see, this is Zen CPD, Zen OCP 4.ibm.lab, the same instance that Brian helped create. So we are running Cloud Pak for data on here, and I have the credentials and I'm signing in. Now I'm signed in here. I have access to the recent projects, analytics dashboard. I have different projects that I can manage from here. I have different deployment that I can watch here. I have different teams that I can log into and can access the different data sets. So over here, if I go, I see different data assets, an overview of environment, jobs. You can get the tour of this. You see there are different CSV files. You can you can drop files here, and so if you have files on your desktop, you can go to the browse and then can upload them here. You can work with different tools by adding assets to your project, so you can build modular flows or add data assets. You can also access SPSS from here. You can access different Watson machine learning instances from here. Once you do that, you can segregate teams into different groups. So you can just add one team and can allocate it to different members, so that whole team would be able to access one project. That's how you can manage the permissions onto that particular asset. You can use runtime environments. You can see them here and define your own environments and monitor active environments. Now coming to the assets, we will quickly see the different functionalities available in IBM Cloud Pak for data. I see auto AI experiments. We have models built out of SPSS. We have modular flows. We have data refineries. So I'll go to this data refinery. This is the data set. These data sets, once imported from your local desktop that lies into a CSV file, can lie here onto your asset management platform. Let's quickly tour the data refinery. You can cleanse and shape. Your data using menu or code. You can view your data as table and different visualizations. You can also watch the metadata, and all the changes can be tracked. And you can select menus and write code. That is a functionality available here. And then work with sample of your data. You see data refinery loads a sample of your data set. So you are able to visualize the sample of your data set. You will know that you're not using string as decimal. So the things like that you can change here. So very useful. And then apply operations. You can apply different operations you can either code them or use a command line to apply those operations. You can add, remove, or modify the steps in your data refinery. So you can do the complete extract transform load, perform the complete extract transform load here. On the profile tab, you can validate the quality of your data and find anomalies. You can also go to the visualization tab, which will go, and then you can run your data refinery flow and save it. So what I'll do is I'll go to the visualization one quickly and see all the different visualizations available here. Inside the data tab, we can edit all the data types onto that table from here. So the flow is like this. You had data on your desktop. You took that data onto this platform, and this platform is connected to your project. You are assigned member of one project that is for a team. And then you are just viewing your data. By the way, you can also connect this data from a database. There are database connections available here. We can connect it from DB2 and so on. So, and then over here you can define the different vehicle types, longitude, latitude. So let's say if I want to use a map, I can go here, define the longitude, define the latitude, and give the tooltip as vehicle type. Can zoom in and do the size of the map as annual kilowatt hour consumption. Now once I go there, I'll be able to see this is a Mercedes. This is the data set that I had, gives me the average kilowatt hour consumption of particular EV onto the map, uh, onto the location where it was sold. So different kind of things you are able to do here. You can change the data type, you can remove duplicates, you can convert column to integer string. So once you have done that, you can go back to your My Projects. Let's say leave this page because this is just a little demo of Data Refinery. Once I'm just trying to explain how I am getting the data onto this platform, and then once I have the data onto the platform, I can launch my RStudio instance. The RStudio instance can be launched from Launch IDE at Cloud Pak for Data. This particular web page shows me the different files that I have uploaded from my local. This is loading my RStudio session. I have already selected the configuration, one virtual CPU and 1 GB RAM. You can change this. If you set up using Power Server that Brian just explained when he was setting up the Cloud Pak for Data onto the Kubernetes platform, the Red Hat OpenShift container platform. This is the RStudio session. It gives me different data sets. I can pretty much perform all the functions that I can do using a normal RStudio. The advantage to this is this has a governance and a lineage piece, so your data is protected, and also that the data you're using in an enterprise is secure to use, and there are different functions that you can utilize. Over here is an application that I can run on. So this is the sales data that I imported from my desktop or from my local to the RStudio. There are multiple things that we can do. How I imported this data set from import, from text base, and I said project data asset, and then that EV forecasting data set that we just watched. All those data sets, the modeling data set CSV, are accessible here. So we can see that we can import the files from Cloud Pak for Data onto the RStudio. Once we have the data over here onto RStudio, we can start coding. In order to start coding, we could just go and say R script, open an R script. We can save file as, save as, and choose a location to save that file. Over here, file name as shiny dashboard, and then save it here. Now this shiny dash.r, we can start coding here. I have what I have done is I got this sales data onto this PEV sales, or the sales data looks like this: Chevy, Volt, Nissan Leaf, Smart, type, different number of years, and a total. Over here I say string PEV sales. I can see it in form of strings. If I'm not putting it into a data frame, I can see it like this in a tabular format. When I'm doing a summary onto one of the columns, I get the summary with a maximum and a mean. I can also do a summary on the type of vehicle. So I'll get the total number of cars in this study, and I'll also get the data type of the column. So data type is character, and total number of cars are 45 plus 10, so 55, and character for the type. I can also do the summary for just for the whole table. So I get the complete summary. I can do a table command onto the whole table here. So I can do a table command onto this column type, so gives me whatever is in the column in form of table, but because it was already existing as a table, so gave me a attempt to make a table greater than number of elements. So there is a limit to the amount of elements that can be into a table. This is for just for the display purposes. Now I want to embed, now let's say if I want to build a simple network, I can go to Shiny package, see if Shiny package is installed, which is an iGraph and then a network 3D, network D3. So it is, now what I'm doing is I'm building a simple network using this PEV sales data from here, and then just defining the height and width of the simple network. Once I've done that, now I'm just running this command. I can see the whole plot with different type of names of the cars that are in this particular network, in this particular table. So let's say RDA3, it would be visible. I can change the colors and increase the font size for a better visibility. So those kind of things I can do. I would just, what I'll do is, just because for the sake of this exercise, I'm going to show this summary and table into that dashboard, how to embed that. I'll run this example really quickly. It's blocking my pop-ups onto here. Let me go and quickly showcase this. So you see there's this data summary that I just was able to print it using the summary command, and a table summary that I was able to print using the table command. And then there is a numeric input where you can give input from here. You can choose the different type of data sets. So cars, for let's say, you can decrease the number of observations you want to consider. And you can also see the code here. The code is in form of in two sections. Number one is UI, which gives me the complete user experience design onto here, and number two is the server, that where you build up your logic. And there is this main panel. What main panel does is, let's say you're building your logic over here into server, where you say you want to render a table. Let's say you want to render a table. You want to render it onto a type called view. You can reference this view and call it here onto the main panel, and then this view is then replicated here. So that's how it's connected using this Shiny app UI and server function. In the server function, you give the logic, in UI you call the logic with the function name. So pretty simple, pretty straightforward. That's how you build your dashboard from scratch. That's how you can leverage direct access to your data, and then you can host it onto your website or onto your localhost, or basically provide the accessibility to different users and customize the dashboard at the same time. You can also connect the real-time feeds here and can provide flexibility to your client or to yourself or to work process in order to gain real-time insights. I hope this was a great session. I hope we were able to cover a lot of details here. In case there are some questions, do please check out our machine learning channel, and I'd post at the end of the today. Looks like today YouTube is down, but definitely do check out our machine learning channel, which I'll provide the link below, and please feel connected. And if in case you are building out a dashboard for your client, you need some help, please do not hesitate to contact. Definitely try to help you out. And if you have any questions on to having a Cloud Pak for data onto Power Systems, do reach out to me or Brian Kelly, and we'll be glad to help. Thank you for joining in today, and thank you for listening. It's a sign from you for you, it's